So hi, today we look at trigonometry. So in trigonometry, we should already be aware of sine, cos and tan. Just in case, let's see where the sine, cos and tan came from. So we all know what's a right angle triangle. And let's say this angle here is theta. Then the longest side opposite to the 90 degrees is hypotenuse. Opposite to theta is called, well, the opposite, and one of the lengths making the angle theta is called the adjacent, because this is next to, right? And we should already be aware of these simple functions. We should be aware of sine. Sine theta is simply opposite over adjacent, opposite over adjacent, Sine theta is opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. So we should be familiar with this from before. And if you look at this to remember it, you always remember so ka tua, or oh hell another hour of arithmetic. Whatever helps you remember it. So we have these functions, and we're now going to go more in depth in these functions: sine, cos and tan. Okay? So if we look up here now, we will see the three representations of cos, for sine and for tan. Sine has a very familiar sinusoidal shape. Cos, very similar shape. And tan is a little bit different. So we're going to spend a little bit of time looking at these functions. So, sine. What can we say about sine? Well, sine starts at 0, goes to a maximum value, comes back to 0, goes to a minimum value, and then goes back to 0. So, sine theta, we can see here, has a maximum value of 1, has a minimum value of -1. What else we could say about sine? Well, if you look at sine, this sine graph, when it reaches here, it will start back here. So the function will continue like that. So it means that the period of this function is 360 degrees. Period means every cycle you will have one of these ways being repeated. So the first 360 you have one, and next 360 you'll also have a next cycle. So every cycle is undergoing in 360 degrees. What's important again? It's important to note that the sine graph, all of these values here are positive. Between 0 and 180, everything is positive. Between 180 and 270, the values are negative. So these are some of the important things with sine. Cos, very similar, has a maximum value of 1 and a minimum value of -1. And this cycle will be repeated again after 360. So it means that the period is 360 degrees. Okay? So, if you look at the cos graph and want to look for similarities, this and this basically looks the same. If I were to blank cut off 90 degrees of sine, it looks exactly like cos if I continue here. So it means that sine and cos are just shifts. So if I shift cos 90 degrees, I'll get sine. If I shift sine back 90 degrees, I'll get cos. Okay? So you will recognize this simple relationship developing, where you have sine theta is cos 90 minus theta. So we'll look at this in a little while. Right? Cos is positive here, negative here, and positive here. Is that okay? We look at tan. Tan now. Tan is a little bit different. Tan doesn't have a maximum value. Tan just goes on and on. But it has something called an asymptote. This tan graph never touches this 90-degree line here. This vertical line never touches this line. This line is called an asymptote. So between 0 and 360, tan has two asymptotes, 90 and 270. What that means is, if you were to find tan 90 in your calculators, you'll get no answer, you'll get error. Right? Means that tan 90 doesn't exist, tan 270 doesn't exist. but it goes all the way up to infinity, all the way down to negative infinity. So if you wanted to say, find what the maximum values for tan and cos were, they were infinity. What is nice about the tan graph is that you look at the tan graph, and the tan graph keeps repeating itself between 90 and 270, or in other words, in a period of 180 degrees. Every 180, you will see tan graph being repeated. So what you can do as an exercise is to draw, for example, between 0 and 720, how these graphs will look. Okay? Tan is positive here, negative here, positive here, negative here. So if you wanted to take all these signs and put these signs on a nice little chart like this, that would help us learn, okay, well, when sign is in the first quadrant, so on and so on. When I say first quadrant, I mean between 0 and 90. Second quadrant, I mean 90 and 180. And it's represented here. First quadrant is between 0 and 90. Second quadrant between 90 and 180. Third quadrant between 180 and 270. And fourth quadrant between 270 and 360. Right. So let's take a look at it. Between 0 and 90, cos positive, sine positive, and tan positive. They're all positive. So we could say sine theta is positive, cos theta is positive, tan theta is positive. Here, sine is positive, cos negative, tan negative. So we just write the ones that are positive. And what about 180 to 270? Sine is negative, cos is negative, but tan is positive. What about the fourth quadrant? Negative, positive, cos is positive, and tan is negative. So this simple graph takes this information and lets us know, okay, well, all are positive here, sine, cos, and tan. Sine alone here, tan alone here, cos alone here. And there's a simple acronym that we use to remember this. All school teachers care. School teachers really do care. So this is a very nice acronym. All school teachers care. Okay? So it helps you remember which quadrant, who is positive. Okay? So we'll come and do some questions on this in a little while. Let's go back to this. There are some values that you must learn, that you must commit to memory. This helps with those values. So some of the values that we must learn, we can see them here. Sine 90. Sine 90 gives us a value of 1. But if I look at this here, sine 90 is equal to cos 90 minus 90, which is 0. So it means that sine 90 and cos 0 must give me the same answer. Let's see. Cos 0 is 1. Yes. Cos 0 is 1. So we could use this to help work out all our values. Sine 0 will be the same as cos 90 if you put it into the formula, and you'll end up with cos 0 is 0, sine 90 is 0. Right? And it can similarly be followed for a set of values. Sine 30, sine 60, and sine 45. Okay? So all these values are values that we should learn. Sine 45 is 1 and root 2, sine 30 is a half, and sine 60 is root 3 on 2. And this will be equal to cos 45, this will be equal to cos 60, and this will be equal to cos 30. Very important values that you must learn. Tan has a few values also, so we can learn values for tan, like tan 45 is 1, right? And there are many other values that we can learn. And these values are important because sometimes they would ask, find the exact value of something, and you must know these, right, to the top of your head. Alright? So, let's take a look at how we solve some of these things now. Let's see how we apply. So we have sine and we have cos. We know about the graphs. We know about how to work them out. So, let's work this out. So, question may ask us, okay, well, solve the following between theta is 0 and 360 degrees. Okay? You want to solve something like this. Let's say they ask us to solve sine theta is equal to a half. So we want all the solution to theta between that will give us a half. What this is something like this. We know what our sine graph looks like. So we want the solutions. So here's 1 and here's a half. We basically want these solutions. We want the solutions when sine theta is equal to a half. That's these two values here. So we are interested in this value and this value. How we find this value is very simple. We go to the calculator, we find theta, carry across sine. The inverse of sine is sine inverse. And we find sine inverse of a half in our calculators. These are values we should know. So this is 30 degrees. But if you look carefully here at the graph, you would see that sine cuts 1 twice. So we should have two answers that will give us a half. Those two answers could come from here. So how do we get those values? Very simple. The value we always get in the calculator theta, once it's positive. The value that we get in the second quadrant, we subtract theta from 180 to get the value in the third quadrant is 180 plus theta. To get the value here is 360 minus theta. What does all that mean? It means that I want to get sine inverse of positive a half. Positive a half, as far as we know, has two solutions. And sine is positive in two quadrants, the first and second. I have the first quadrant answer, so I need the second quadrant answer. How do I do that? The second quadrant answer is simply in this quadrant, so I take theta and I minus it from 180. So that will be 30 and 150. Okay, so I have my two solutions. This will be 30 and this will be 150. Right? That's the way you solve this simple function. In a later episode, I will do many more examples. Okay? So now it's time. So now that we have an idea how to solve, we need to take a look at identities. No one likes ideas. Right? So there's some identities that we must know. Right? So identities. Right? Some we know already. We know tan theta, the sine theta over cos theta. And next very popular identity is the identity sine squared theta plus cos squared theta is equal to 1. Right? And we can look at this for further time. So based on identities, let's see if we can solve something. Right? So we want to solve something as simple as this. We want to prove that, right, so we would like to prove something. We would like to prove cos squared over 1 minus sine theta is equal to 1 plus sine theta. So we start working initially with our left hand side. Left hand side is this side here. So you want to make this side look like this side. So this side has cos, this side only has sine. So we need to get rid of that. So let's start. So we have cos squared theta over 1 minus sine theta. How do I eliminate cos squared theta? Well, if I look at this identity, I will see cos squared theta is equal to 1, carry across the sine squared, 1 minus sine squared theta. So I can use that here. I can say, well, okay, cos squared is 1 minus sine squared theta over 1 minus sine theta. No more cos, there's only sine. So we need to figure out now, okay, how am I going to get 1 plus? So if you look at this carefully, this is really squared 1. So this resembles difference of two squares. 1 squared minus sine squared, which can also be written as 1 minus sine theta, 1 plus sine theta. Right? And this is all over 1 minus sine theta. If you look closely, this will cancel with this. And we'll be left with 1 plus sine theta, which is what we asked to prove in the beginning. So, draw a little box so we can write QED, which means prove it. Okay?